Intermittent fasting has emerged as a compelling lifestyle intervention that taps into the body's ancient stress adaptation systems, with autophagy at the center of its beneficial effects. By cycling between periods of eating and fasting, typically ranging from daily time-restricted feeding to alternate-day fasting, this practice induces a metabolic shift that activates autophagy. In doing so, intermittent fasting supports cellular repair, metabolic efficiency, and immune resilience, contributing to delayed aging and potentially reducing cancer risk. During fasting, nutrient availability drops, leading to a decrease in insulin and activation of key energy-sensing pathways such as AMPK and inhibition of mTOR. This metabolic state mimics the conditions that historically signaled the need for internal conservation and cleanup. In response, autophagy is upregulated, allowing cells to break down damaged proteins, organelles, and accumulated waste. This process is more than just cellular housekeeping. It refreshes the internal environment of the cell, prevents oxidative stress, and restores homeostasis. Over time, repeated activation of autophagy through intermittent fasting appears to attenuate several hallmarks of aging. It reduces systemic inflammation, improves mitochondrial function, and enhances insulin sensitivity. These benefits not only promote healthier aging but also intersect with several mechanisms implicated in cancer prevention. By reducing chronic inflammation and oxidative damage, intermittent fasting limits the environmental triggers that can initiate malignant transformation. It also improves DNA repair capacity and supports immune surveillance, key defenses that typically erode with age and are known contributors to increased cancer risk. In animal models, intermittent fasting has consistently shown the ability to extend lifespan and reduce the incidence of spontaneous tumors. These effects are likely mediated in part by autophagy, but also by other metabolic shifts such as reduced IGF-1 signaling and improved hormonal balance. In humans, while long-term data are still emerging, short-term studies have shown reductions in biomarkers associated with cancer risk, including insulin, C-reactive protein, and oxidative stress markers. The adaptive stress imposed by fasting appears to prime cells for resilience, improving their ability to respond to damage without tipping into disease. However, the impact of intermittent fasting on established cancers is more complex. In some cases, fasting may enhance the effectiveness of chemotherapy by sensitizing tumor cells to treatment while protecting normal cells through stress resistance. Yet in other scenarios, especially in cancers that rely on autophagy for survival, fasting-induced autophagy could theoretically provide a survival advantage. This dual nature, autophagy as both a protective and a permissive force, demands careful consideration when applying intermittent fasting in clinical oncology. It may be beneficial in prevention or early-stage disease, but must be cautiously managed in active cancer patients, especially those with cachexia or compromised nutrition. Intermittent fasting also raises practical concerns when applied over the long term. While many people tolerate it well and report improved energy and focus, others may experience fatigue, nutrient deficiencies, or disrupted circadian rhythms if the regimen is too extreme or poorly aligned with their lifestyle. Furthermore, in older adults, the balance between promoting autophagy and maintaining adequate nutrition becomes increasingly delicate, as both undernutrition and overactivation of stress pathways can be detrimental in aging bodies. Nevertheless, when implemented thoughtfully, intermittent fasting represents a powerful, non-pharmacological tool to activate autophagy in a manner that supports longevity and potentially lowers cancer risk. Its cyclic nature mimics the feast-famine rhythms that shaped human evolution, helping to reset biological processes that deteriorate with constant caloric abundance. By integrating periods of strategic stress with phases of recovery and nourishment, intermittent fasting offers a dynamic way to align with the body's intrinsic repair systems, supporting health not through deprivation, but through intelligent metabolic modulation.